Hello everyone, welcome back. So in the previous video, in case of horizontal scaling, we had discussed that we need some manager in the middle, some manager who will take care of which request should be going to which server, right? Now who this manager is, we'll be looking into that in this particular video. Okay, so that manager is called as load balancer. Okay, it's a load balancer who will do all the managing part that we had discussed. So we'll now be looking into what a load balancer is. Okay, so what does a load balancer do? First thing, as the name suggests, it prevents the resources from being overloaded. Okay, so it has got n number of requests, n number of incoming requests, and it redirects the request based on certain criteria. It will redirect the request to different servers. What those criteria are, we'll be discussing them shortly. But based on certain criteria, it distributes the load between different servers. So its first task is prevent the resource from being overloaded. Okay. Next thing is that, let's say during like while operations, some server goes down. Okay. Now it is the responsibility of this load balancer to redirect the request only to the healthy servers. Okay, it is responsibility of this server that the next incoming request should not be going to a server that is not live. Okay, so it prevents requests from going to unhealthy servers. Now it is the load balancer which enables system to have multiple servers, right? So it is enabling system to have more than one server. So load balancer enables system to eliminate single point of failure. Now this load balancer could be implemented in both hardware hardware form, or you can implement it in the form of software as well. Okay, now we discussed that load balancer have certain criteria for distributing the load. We'll now be seeing what those criteria are. Okay, so what can be the easiest criteria for deciding? Randomly send the requests anywhere. Okay, so whenever you have an incoming request, randomly select a server and send the request to any of these servers. But this approach certainly have problems. Why? It may be randomly sending a large amount of requests to server A and server D, but very less amount of requests to server C and server B. Okay, so this is not actually balancing the load. So randomly distributing requests is not an appropriate way of balancing the load. Okay. Okay, so load balancer can you look at various metrics and decide which load balancer should which server should it be sending the next request. So these metrics could be active connections, active connections, or least amount of traffic, or response time. Okay, so a load balancer can look at what are the active connections on a particular server, and it can select a server with least number of active connections. It can look into how much traffic is present on each of the server, and it can select a server with least amount of traffic. Traffic is measured in Mbps. So whatever server will have least amount of traffic, it can redirect its next request to that particular server. If it wants very fast response, it can redirect the request to a server with least amount of response time. So these are certain metrics that a load balancer can use to redirect its traffic. What is in another way? It can use round robin. So if you have certain requests coming in, you can send first request to A, second to B, third to C, fourth to D. Again, then when request comes, you can send next set of requests in same fashion. So 1 2 3 4 request goes here, fifth request can come here, sixth can come here, seventh can come here, and eighth can come here. Now this particular round robin thing has got a problem. What? We know that in horizontal scaling the servers may have different capacities. Okay, they may have different configuration. Because of different configuration, server A can serve, let's say, 25 requests in 1 second. Server C can serve 50 requests in 1 second. Server B can serve 75 requests in 1 second, and server D can serve 100 requests in 1 second. Okay, so now each server has got different capacity, and because of round robin, if you see, everyone gets almost equal number of requests. So because of round robin, say every server has got to serve 60 requests per second. Now 60 requests per second are not fair for A and C. Why? Because A can serve only 25 requests per second. C can serve only 50 requests per second. So they are much more loaded than their capacity, whereas B and D are loaded less than their capacity. So this is not a fair distribution. This is the problem with round robin. How can we fix this problem? We can fix this problem by using weighted round robin. Yeah, so in order to do weighted round robin, find a server with least capacity. So here server A is the server with least capacity. It can serve only 25 requests per second. Now we'll find the relative capacity of all other servers B, C and D with respect to A. So in order to do that, we'll divide each server's capacity by server A's capacity. So we'll get 1 here, 75 by 25 we'll get 3 here, we'll get 2 here, and we'll get 4 here. Now just add all these numbers and you get 10, right? Now what these numbers are, these numbers actually mean that out of 10 requests, 10 incoming requests, 1 request should go to server number A, 3 requests should go to server number B, 2 requests should go to server number C, and 4 requests should go to server number D. So this is what is a distribution of requests based on server's capacity. It is fair distribution. It is not equal. It is fair distribution based on server's capacity. Now how would we do round robin in this particular thing? So these are capacities out of 10. Okay, now say there are incoming requests. So first request can go to this server, second would go here, third would go here, fourth would go here. After this, after one iteration, we'll check if there are servers who have reached their maximum capacity out of 10, and server number A has reached its maximum capacity out of 10. So now when next set of requests come, they will go only to B, C and D. So fifth can go here, sixth can go here, seventh can go here. Again we check if there are servers who have reached their maximum capacity. Yes, server C has got 2 capacity and it has reached maximum capacity. So next set of requests would go only to server B and server D. So 8th will go here, 9th will go here. Again we check if there are servers who have reached their maximum capacity. Server B has reached its maximum capacity and next request would only be going to server number D. So this server will get the 10th request. Again, since the 10 requests are done, 11th request can again go from A to D, A, B, C, D. 11th will go to A, 12th would go to B, and so on. Okay, so this is round robin. Now in this case, if servers are loaded, all servers would be loaded, and if servers are serving requests below their capacities, then actually all servers would be serving below their capacities. Okay, so this is how weighted round robin distributes the requests fairly. So from the discussion so far, we know that the load balancer is routing traffic. It has got incoming request and it decides where should that request go to, which server should that request go to. Okay. Now, based on different kinds of use cases or different kinds of application, we can select load balancers that work on different layers. Okay. So load balancer can operate on layer number 4 of ISO OSI model. Fourth layer, that is transport layer. Or it can operate on 7th layer of ISO OSI model, which is application layer. Okay, we'll be looking both these layers into detail, starting with the transport layer. Okay. So any packet that is coming in or going out from the transport layer will have this particular data. It will have source IP address, it will have destination IP address, it will have source port number, and it will have destination port number. Okay. Now if you see, all these servers are present in a private network. So these servers will have private IPs, but the packets that are coming in and going out into the internet, they will have global IPs. Okay. So any load balancer that is operating on layer number 4 will have to do the conversion of global IPs into private IPs and private IPs into global IPs. So this conversion of global into private and private into global IPs is called as network address translation. So any load balancer that operates on layer number 4 or transport layer uses network address translation for routing all the packets. Okay. Now consider an enterprise which have implemented things in this particular way. So it has one server dedicated for video data, it has one server for audio data, one for images, let's see, and one server for business critical use cases like payments and billing. Okay. Now this load balancer has to decide which server should be serving the request. In order to do this, load balancer needs the ability to look into what kind of message is present in the packet that is incoming from internet. Okay. Now in order to look into the message, it needs to have the capability to look at that message. For such kind of use cases, we use the load balancer which operates at layer number 7, that is application layer. Okay. Why application layer? Because any message that is coming in and going out of layer number 7 will have everything that is present at layer number 4. It will have much more things that is not relevant for this discussion. Apart from that, it will have the actual message. Okay. So a load balancer that operates at layer number 7 will have ability to see this message. Okay. Now based on this message, it can decide if a video is being requested, then it will route its request to the server number A. If it is asking for images, it can route its request to server C. If it is asking for computing the bill generated or for payments, it can go to server number D. So for this kind of distribution of request, we use load balancer that operates at layer number 7. Okay. We'll now be looking at what problems we can have when we use a load balancer. So first thing is that we discussed that load balancer is actually helping eliminate single point of failure, right? But in this case, if we have a system with only one load balancer, and if this particular load balancer fails, then actually one load balancer itself becomes single point of failure, right? Then consider a case where the network from where the requests are coming have 1000 mbps bandwidth. The network which is serving those requests have 750 mbps of bandwidth, but our load balancer, it is operating only at 450 mbps. Then it will bring down the bandwidth of complete network to 450 mbps, right? Because requests going out of the load balancer are always at 450 mbps only. So a load balancer can act as a bottleneck. A load balancer can act as a bottleneck. Now, having a load balancer is a complicated thing. Why? You have to implement many things at this particular layer of the network. So you have to implement the algorithms for distributing the load. You'll have to implement things to look at the servers which are healthy, which are not healthy. You have to redirect requests only to the healthy server. So it adds complexity to the network. Okay? Having a single load balancer is itself a complicated thing in a network. It adds latencies as well because of these complexities. Now, if we try to eliminate the first problem, okay, single load balancer can act as a single point of failure. If we add one more load balancer which has got same capabilities as this particular load balancer, then it makes system even more complicated, right? So these are the problems associated with having load balancers in the system. I hope you would have understood this. Thank you.